We're going to talk through all of these do nows and take a look at the language that's in there that gives us clues about which equation is correct for the word problem. So the first one, a cookie jar starts off with 32 cookies in it, and each day 2 cookies are eaten. After a certain number of days, there are 14 cookies left in the jar. Which of the following equations represents the day D when there are 14 cookies in the jar? Okay, so let's start looking at information. We have 32 cookies in the jar. That's the first piece of information we're giving. So if you think about 32 cookies, that's never going to change, right? The jar starts off with those 32 cookies. I know if it doesn't change, that's the constant. Each day, 2 cookies are eaten. So depending on how many days have gone by, that relates to how many cookies were eaten. So that changes based upon the number of days. That's where our variable is going to be. That's always what changes. After a certain number of days, so all of that, at the end, we get 14 cookies left in the jar. So that's what we have at the end. That gives us the clue about what our equals is going to be. So if we look at all these choices, 14 is all the equals. So we're good there, right? It's still going to be any of them. Doesn't help us eliminate it. So we have 32 cookies that does not change. So 32 has to be a number by itself, not attached to a variable. So the first one has that, right? 32 is right there. The second one does. The third and the fourth, C and D, both have 32 multiplied by the variable, attached to the variable. So these two we're going to cross out. And then if we're eating cookies, we have to think about, okay, so are we adding cookies into the cookie jar, or are we subtracting cookies from the cookie jar? And obviously, if we're eating them, we're subtracting cookies from the cookie jar. So we know for this one, A is the correct answer. Next one says, your piggy bank starts off with $3. Starts off with $3, not going to change. I wanted that to be yellow. $3 doesn't change. Each day you put $2 in it. So we have that word each again. Each day you put $2 in it. So you're adding $2. So you have 3 plus 2 with a variable. At the end of the day, there's $19 in your piggy bank. So we're all going to equal 19. We said that 2 is attached to the variable. It's each day. And then we're starting off with 3 as our constant. So we're going to look again only at A or B because this has 3. Oh, nope, C has 3 as a constant also. So we know that we can cross out D. So let's take a look at what we have. We start out with 3 and then we're adding money to it. Well, this is the only one that has adding in it, right? So our correct answer for this one is B. One day, your aunt gave you 20 pieces of candy. That's what she gave you. Doesn't change. Gave you 20. You ate 2 pieces each day. After a certain number of days, there are 10 pieces left. Which of the following equations represents the day D when there are 10 pieces left? Okay, so we have all of these equal 10. We start out with 20 by itself. Well, that one doesn't have 20 as a constant. That one does, this one does not. So we have 2 equations left to look at. We're eating 2 pieces, so we're taking 2 pieces out of that pile and eating them. So we're subtracting them out of that pile. So we have minus the 2 pieces. And our answer for this one is C. A book has 150 pages. Doesn't change. 150 pages is constant. You read 3 pages per day. Pages per day. Per is another one of those words that lets you know that you're talking about something that changes depending upon the number of days. So 3 pages per day. If you read for 2 days, that's 6 pages. If you read for 4 days, that's 12 pages. So it all depends on the number of days. After a certain number of days, there are 60 pages left. So this is telling us what it equals. Which of the following equations represents the day D where there are 60 pages left? So we said it's going to equal 60. And we have a constant of 150. That is by itself. That only applies to A and B in this problem. We want to know when there's 60 pages left. So we're taking that total pages and we're subtracting from it to get down to how many are left to read. So we're subtracting those 3 pages per day. So we know in this problem, our correct answer is A. A carnival charges $5 to enter. You walk in, you have to pay $5. $2 per ride. There's that per word again. If you pay a total of $23, so that's what you're paying at the end of it all, which of the following equations represents the number of rides R you win on at the carnival? So looking at our choices, there's our 23 at the end. We said $5 is our constant. That doesn't change. You walk in, you have to pay $5. So that eliminates these 2 equations. Then we have to think about, okay, so we're paying the $5. Are we adding more money to what we've paid after we've gone on the rides? Or are we taking money away from what we're paying? So even though the money's coming out of our pocket, it's kind of adding into that amount that we've paid out. So we have the $2 per ride plus the $5. This is what we spent, and all that we spent equals $23. So our correct answer for this one is C. At first, you have 15 bottles of Coke, and you drink 2 bottles each day. After a certain number of days, there are 3 bottles left. That's what we ended up with. Which of the following equations represents the day D when there are 3 bottles left? So we have our 3 bottles left at the end. And we start with 15 bottles of Coke. That never changes. So we have a constant of 15 here and a constant of 15 there. So out of that 15 bottles, we're drinking 2 bottles each day. We're taking 2 bottles out of the refrigerator and drinking them. We're subtracting them out. So if we look at our choices, this is the subtraction one. So our answer for this one is D. Okay, you're going to go back to your Google Classroom. Make sure you copy down the notes. There's a lot of word problems, so if you have them written out ahead of time, you'll really be able to take notes and follow along as I go through the next video.